Hello everyone, welcome to today's presentation on fractals in the simplest form. My name is Jordan Seifert, and during today's presentation we'll be taking a closer look into section 7.1, introducing the basics of fractals and imaging. First, we should ask ourselves a few questions pertaining to the subject. What exactly are fractals? Where did they come from? And finally, what are the famous Mandelbrot sets? Fractals carry a few unique characteristics that make them significant in the math world. With fractals presumably being geometric shapes, they are not definable by Euclidean geometry, which is considered normal geometric shapes. Fractals are quite simple when looking at images, objects, and nature. To be able to solve the height of a smaller object to a larger object, all we do is simply trace a smaller object, then divide 1 by the number of small traces that fit into the larger one. I want you all to begin to imagine a head of broccoli. We'll get back to that in a few slides. Beginning in 1920, Gaston Julia introduced the idea of fractals, creating a series of collections. These collections of objects were first known as Julia sets. 50 years after the origin of Julia sets, an inspiration for a new revolutionary theory began to develop. During the years of conceptualizing this idea of fractals mixed with imaginary numbers, there was a real desire for this new math. In the late 1970s, Benoit Mandelbrot was able to lay new groundwork in creating a Mandelbrot set. The Mandelbrot set was later used in computer graphics, creating images from these sets. Mandelbrot was the true inventor of the fractal world. Using these two images, we are able to take a deeper look into fractals. Look closely at the Sierpinski triangle. If you continue to hit the zoom button, what would you see? The topic of fractals pertains to imaginary numbers in the math world. When focusing on this section specifically, we see fractals prevalent in imaging. A fractal is a geometric shape that can be split into parts that are similar but smaller than the original shape. In these images, we are able to pick a certain point, magnifying the image down to a much smaller size. A magnification is an enlargement or to make bigger. With fractals, the substructures are smaller structures that look like the original one when being magnified. The two problems that I have chosen to demonstrate from this section are fairly easy for most to understand. The concept itself pertains to seeing a smaller image inside of a bigger one. First, I chose to solve the incredible shrinking duck. Here's the question. On the quacked wheat box, outline the sub-picture that is an identical, but reduced copy of the whole picture. Roughly, what fraction of the height is the reduced picture compared to the whole? Second, I am demonstrating blooming broccoli. Statement, in the bunch of broccoli, find 3 sub-bunches that look nearly identical to the whole bunch. Which would you rather eat, the whole bunch or the sub-bunch? The solutions will be presented after the following slide. Here are the two images pertaining to the questions previously. For question 1, to determine what fraction of the height the smaller picture is compared to the whole thing, you must trace the smaller height and see how many fit into the larger one. Afterwards, you conclude that approximately 3.5 smaller heights fit into the larger height. Finally, we divide the larger height, 1, by the smaller height, 3.5, and get the fraction 2/7. Secondly, for blooming broccoli, we must use our best judgment. As we can see, a large head of broccoli is just smaller ones put together to make one big head of broccoli. Which one would you rather eat? Finally, what I was able to learn, I was able to get a good understanding of fractals in this section and how they are seen in imaging. Also, I was just fell on the notion that math is everywhere in this world, no matter what you usually look at. Overall, it was interesting learning about the math historians that came into play for this particular subject in math. To finish up, let's watch a small video on fractals to see why they are so important in the world today.